NEC Article 430, which covers motors, controllers, and motor circuits, does not specifically address actuators for commercial heating, ventilation, and air conditioning dampers. However, several considerations suggest that these actuators are not subject to the disconnect requirements outlined in 430.101. Firstly, let's consider the definition of a motor. Article 100 defines a motor as a machine that converts electrical energy into mechanical energy. While actuators do convert electrical energy into motion, they typically do not provide the primary motive force for a system. Instead, they are generally used to control the position or movement of other devices, such as dampers. Secondly, the intended use of heating, ventilation, and air conditioning dampers is primarily to regulate airflow within heating, ventilation, and air conditioning systems. Actuators facilitate the remote operation and control of these dampers. They are not designed to provide continuous power or motion in the same way as motors that drive machinery or appliances. Thirdly, NFPA 90A, which is an accepted industry standard for electrical installations in air conditioning and refrigeration systems, does not classify actuators for heating, ventilation, and air conditioning dampers as motors. Instead, it includes them in Chapter 44, which covers controllers and remote control circuit devices. Fourthly, most manufacturers of heating, ventilation, and air conditioning damper actuators do not classify their products as motors. They typically categorize them as dampers or control devices. Based on these considerations, it is reasonable to interpret that actuators for commercial heating, ventilation, and air conditioning dampers are not considered motors under NEC Article 430. Therefore, they are not subject to the disconnect requirements of 430.101. However, it is essential to note that this interpretation may vary depending on the specific application and any local code requirements that may be in place. It is always advisable to consult with a qualified electrician for a professional assessment to ensure compliance with all applicable codes and regulations. To further clarify the classification of heating, ventilation, and air conditioning damper actuators, it's helpful to delve deeper into their function and operation. Actuators are essentially control devices that use electrical energy to precisely position dampers. They receive signals from a control system, such as a thermostat or building automation system, and respond by adjusting the damper's position to regulate airflow. The amount of power required for this operation is typically relatively low compared to that of a motor designed to provide continuous motive force. Moreover, the operating characteristics of actuators differ significantly from those of motors. Actuators typically operate intermittently, moving dampers to specific positions and then holding them there. Motors, on the other hand, are often designed for continuous operation, providing sustained rotational force. The control circuitry associated with actuators is also distinct from that of motors. Actuators often incorporate sophisticated electronic components that allow for precise positioning and feedback. This level of control is not typically found in standard motor control circuits. In addition to the factors already discussed, it's crucial to consider the implications of classifying heating, ventilation, and air conditioning damper actuators as motors under NEC Article 430. If actuators were to be classified as motors, they would be subject to a wide range of requirements, including those related to overcurrent protection, conductor sizing, and motor disconnects. These requirements are primarily intended to protect motors from damage due to overload or fault conditions. Applying these requirements to actuators could result in unnecessary expense and complexity, as actuators are generally not susceptible to the same types of failures as motors. Furthermore, the disconnect requirements of 430.101 are intended to provide a means of disconnecting motors from their power source for maintenance or repair purposes. While it is certainly important to be able to disconnect actuators from their power source, the disconnect requirements for motors may not be appropriate for actuators. Actuators are often integrated into complex control systems, and disconnecting them without proper consideration could disrupt the operation of the entire system. It's also important to consider the potential impact on building automation systems. Modern buildings often rely on sophisticated automation systems to control heating, ventilation, and air conditioning systems, lighting, and other building functions. These systems use actuators to precisely control dampers, valves, and other devices. Classifying actuators as motors could have a significant impact on the design and operation of these systems. It could also lead to increased costs and complexity, as building automation systems would need to be designed to comply with the motor control requirements of NEC Article 430. In summary, the classification of heating, ventilation, and air conditioning damper actuators is a complex issue that requires careful consideration of various factors, including the definition of a motor, the intended use of actuators, relevant industry standards, and the potential impact on building automation systems. While NEC Article 430 does not specifically address actuators, the available evidence suggests that they are not considered motors under the code. Therefore, they are not subject to the disconnect requirements of 430.101. It is important to emphasize that this interpretation is based on the information currently available and is subject to change as new information becomes available or as the NEC is revised. It is always advisable to consult with a qualified electrician or electrical engineer for a professional assessment to ensure compliance with all applicable codes and regulations. Moreover, it's important to remain updated on any changes or interpretations related to electrical codes and standards. The NEC is updated every 3 years, and interpretations of the code may evolve over time. Staying informed about these changes is crucial for ensuring that electrical installations are safe and compliant. Here's a further breakdown of key considerations. 1. The definition of a motor, as previously mentioned, is a critical starting point. Article 100 of the NEC provides definitions for various electrical terms, and understanding the definition of a motor is essential for determining whether a device falls under the scope of Article 430. 2. The intended use of the device is another important factor to consider. Actuators are primarily used for control purposes, while motors are typically used for providing motor force. This distinction is important for determining whether the requirements of Article 430 are applicable. 3. Industry standards, such as NFPA 90A, can provide valuable guidance on the classification of devices. These standards are developed by experts in the field and reflect accepted industry practices. 4. Manufacturer classifications can also be helpful. Manufacturers typically classify their products based on their intended use and operating characteristics. These classifications can provide insights into whether a device is considered a motor or a controlled device. 5. The potential impact on building automation systems is an important consideration for larger installations. Building automation systems often rely on actuators to control various building functions, and classifying actuators as motors could have significant implications for the design and operation of these systems. It's also important to consider the role of local codes and regulations. While the NEC is widely adopted, local jurisdictions may have their own amendments or interpretations of the code. These local requirements should always be taken into account when determining the classification of electrical devices. Another aspect to consider is the type of actuator being used. There are various types of actuators, including electric actuators, pneumatic actuators, and hydraulic actuators. The type of actuator may influence its classification under the NEC. For example, pneumatic and hydraulic actuators may not be subject to the same requirements as electric actuators. Furthermore, the voltage and current requirements of the actuator should be considered. Actuators typically operate at relatively low voltages and currents compared to motors. This difference in operating characteristics may be a factor in determining whether the requirements of Article 430 are applicable. In addition to the above considerations, it's important to document the rationale for the classification of heating, ventilation, and air conditioning damper actuators. This documentation can be helpful in demonstrating compliance with the NEC and in resolving any disputes that may arise. The documentation should include a description of the actuator, its intended use, relevant industry standards, manufacturer classifications, and any other factors that were considered in the classification process. Moreover, it's essential to ensure that all electrical work is performed by qualified personnel. Electrical work should only be performed by licensed electricians or other qualified individuals who have the knowledge and skills necessary to ensure that the work is done safely and in compliance with all applicable codes and regulations. The NEC is a complex document, and interpreting its provisions can be challenging. It's always advisable to seek the advice of a qualified electrician or electrical engineer when in doubt. These professionals have the expertise to interpret the code correctly and to ensure that electrical installations are safe and compliant. In conclusion, the question of whether heating, ventilation, and air conditioning damper actuators are considered motors under NEC Article 430.101 is a nuanced one that requires careful consideration of various factors. While the available evidence suggests that they are not typically classified as motors, it's crucial to consult with qualified professionals and to stay informed about any changes or interpretations related to electrical codes and standards. The goal is to ensure that electrical installations are safe, compliant, and effective in meeting the needs of the building and its occupants. Additionally, continuous education and training are vital for electricians and other electrical professionals. Staying abreast of the latest technologies, code changes, and best practices is essential for providing high-quality electrical services. This includes attending workshops, seminars, and online courses, as well as reading industry publications and participating in professional organizations. Furthermore, it's important to foster a culture of safety within the electrical industry. Safety should always be the top priority, and all electrical work should be performed with caution and in accordance with established safety procedures. This includes using appropriate personal protective equipment, following lockout/tagout procedures, and conducting regular safety audits. The electrical industry plays a crucial role in ensuring the safety and reliability of electrical systems in buildings and infrastructure. By adhering to codes and standards, promoting safety, and investing in education and training, electrical professionals can contribute to a safer and more sustainable future. To reiterate, the interpretation of whether heating, ventilation, and air conditioning damper actuators fall under the motor classification of NEC Article 430 is based on a few key factors. 1. Actuators primarily serve a control function, regulating airflow rather than providing continuous mechanical power like traditional motors. 2. Industry standards such as NFPA 90 categorize actuators as control devices rather than motors. 3. Manufacturers typically classify these components as dampers or control devices, not as motors. 4. Applying motor-specific requirements like those in 430.101, such as motor disconnects, may be unnecessarily burdensome and not aligned with the operational characteristics and lower power demands of actuators. However, one must always check local amendments, which can override the NEC general guidelines, so always consult the local authority having jurisdiction or urge to make sure your area does not have any special requirements. Also, document every step in your thought process. If you think you have reached a correct decision, write down all the steps and information that you used to get to that decision. Should an inspector come along later and question your work, you'll be able to demonstrate why you did what you did and what you based your information on. It shows that you've done your due diligence and that you are not just trying to cut corners or ignore the code. So in short, consult the local codes, consult the local HA, and document everything.